This unit is about organizing knowledge in long-term memory. And of course, again, we focus on organizing declarative knowledge and organizing procedural knowledge. First, declarative knowledge. The basic idea you might have is that knowledge is represented in human memory, in long-term memory, in the form of nodes, of networks of nodes. So we have nodes which are connected, as you may think of neurons being connected through axons, and these neurons together form a network, and this network of nodes is how knowledge is stored, basically. But still, you can then try to imagine that there are various ways in which concepts are stored in networks, which together form, for instance, theories or rules of theories or bigger organizations of knowledge, basically. In cognitive psychology, three major distinctions have been made. Three major organizing principles have been distinguished as far as the storage of concepts in long-term memory is concerned. Feature-based networks, prototype-based networks, and concepts as family resemblances. We will discuss each of these three types of organizations. The most straightforward idea is perhaps the encyclopedic idea, which is depicted here as an organization of nodes on the basis of features. So on top here we have animals. And animals have all kinds of characteristics. They have a skin, they can move around, they can eat, they breathe. So these are animals as distinguished from other organisms like plants or microorganisms, which have also different characteristics. Animals do have a skin, they can move around, they do eat, and they breathe. Now, as a subdivision, you can think of mammals, of course, they are not here in this organization, but we can think of birds and of fishes. And birds do have wings, they can fly, and they have feathers, whereas fish have fins and can swim and have gills. And so we can go on to further specify, kinds of birds like canaries and ostrich, and kinds of fish like sharks and salmons. And so we can gradually go on into these hierarchies of concepts, basically. So the feature model is a hierarchical model. And you can imagine that at every level, a concept inherits all characteristics of its parents. So birds do have skins, they also can move around, they can eat, and they can breathe. So they have all the characteristics which animals have. And that makes this kind of organization a sort of, efficient. So you at every level in the organization, you specify the unique characteristics which distinguish the particular concept from other concepts at that level. So then you get taxonomies, as it is called, of concepts in which in each taxonomy every concept is, let's say, unique and can be distinguished from the other concepts in that particular taxonomy, mutually exclusive, so to speak. So there can not be animals which are together, which are both at the same time birds and fish. Although of course in children's stories you may encounter those kinds of animals. Okay, so that is a sort of logical organization. You can imagine that this makes sense to make these distinctions and to arrange concepts in such a way. And you can, of course, do all kinds of experiments in which you try to figure out whether children, when they have learned something and they are asked to draw a network of the concept they have acquired, they organize a network in such a way. Makes sense. There is another solution for this problem, how concepts are organized in semantic memory. And that is the prototype kind of organization. In this organization, you do not have such a logical network, but you do have sort of, a prototype kind of bird, which most people mention as a first example of a bird when they are questioned. Give me an example of a particular concept. Give me an example of a particular bird. Most people do mention the robin as a very very birdy bird, so to speak. So you can give all kinds of birds birdiness rankings, as it is said here in this example, and then you will discover that some birds are more central and other birds are more peripheral, like the ostrich, which is not a very typical, prototypical example of a bird, because it walks, it doesn't, well, I don't know whether it flies, but it usually doesn't fly. The penguin is also such a non-prototypical example of a bird. And you may, of course, think of animals which perhaps are not easily distinguished as either a bird or a mammal or whatever, or a fish or whatever. So we do have the canary here, a very central, and other birds which are very, the owl, as also the duck, are quite, well, they're becoming a little bit less prototypical. The peacock is even more less prototypical, etc. So you can organize your knowledge in such a way. That is the way in which Eleni Ross studied, the way people use concepts. You can imagine that it depends a bit on your experience in a particular field, what for you is a prototypical example. For instance, for us, the robin might be a prototypical bird, but when you are a bird watcher or an expert in this field, then you may have a bird on a very low level, of detail, which is your prototypical bird. When you think of a table, for instance, then you may think of just a rectangular table. But when you're an expert in tables, you might think of very different kinds of tables as prototypical. So your experience determines what you consider as a prototypical exemplar of a particular concept. So therefore, the prototype theory is a bit more flexible, let's say, than the feature theory we had before, because prototypes, the organization of instances, of exemplars of a particular concept gradually evolves out of your own experience with a particular domain. Now these two theories do distinguish between exemplars and non-exemplars. So either you are a bird, a particular animal is a bird, or it's not a bird. Whether you have a feature theory or a prototype theory, you tend to think that there is either a yes or no decision about the applicability of a particular concept to an instance of that concept. But the third theory about the organization of knowledge is even more, let's say, open in that sense. This was originally, I think, the ideas were developed by Ludwig Wittgenstein, in which, his idea is that there are, you cannot easily say that exemplars of a particular concept do have all the characteristics of that concept, like we saw in the feature theory. Every animal has a skin and can breathe, etc. Well, here we do have the family, let's say the family Smith, and these are all brothers, in this family, and these brothers do have all kinds of characteristics, but they do not have all characteristics in common. For instance, one of them is bald and the other 5 members of the family have hair. Most of the, I think, again, 5 Smiths do have freckles, and 1 doesn't have freckles. But still, as you see this picture of the 6 brothers of Smith, you can easily recognize them as being a member of the family, although it is not easy to identify all distinguishing characteristics. As a matter of fact, there is not a set of distinguishing characteristics, but there is something like a combination of characteristics in most of the members of the family, which makes them a typical example of the family, of the Smith family. And so you have this what family resemblances theory, as Wittgenstein called it, which is, let's say, characteristic of this sort of organization of concepts in a semantic network. So interestingly, we do have various ways in which we can think of the organization of concepts in a semantic network. And it is interesting to compare these 3 different characteristics and see what the advantages and disadvantages are. And you can imagine that you may arrange experiments in which participants have to decide on, let's say, the fact whether a particular instance is an instance of the family bird or not. And you can imagine that as long as it takes longer to identify the family resemblance, so to speak, it may either, let's say, indicate a feature type of theory or a prototype theory or a family resemblance theory. So that is what people have done, actually counting seconds when participants had to decide whether a particular stimulus was an example or not of a particular concept. Okay, now we have been discussing transfer already, I think, but again we will focus now on transfer as a way of conscious abstraction. We discussed these network theories as, let's say, organizational principles, so to speak. So you can make use of those principles to make a conscious abstraction. You can try to extract, the characteristics of the Smith family and use these characteristics to identify another member of the family or another person which you encounter as being either a member or not a member of the Smith family. Because you have some idea of, these hairs and these freckles and other characteristics of the Smith family, and when you encounter a particular person, you might use these, let's say, these characteristics to identify, to decide on the question whether or not this particular person is a member of the Smith family. Now, that is what we call a sort of high road transfer, a conscious abstraction of characteristics which you use in a new situation in order to be able to use the concept to decide on whether or not a particular stimulus is an example of the concept or not. Okay, now we move on to organizing procedural knowledge. And here we encounter the model which I already announced, the model of John Anderson about the acquisition of cognitive skills. I already said that there is a sort of gradual change from strategies to skills. And that is what John Anderson called the ACT-R theory, in which 3 stages are distinguished: the cognitive stage, the associative stage, and the autonomous stage. Let me briefly explain what each of these stages entail. Imagine that you have to learn by heart a particular piece of music to play it on the piano. Now you have the score in front of you, and you have these notes, and you do recognize the notes, and you can easily, let's say, name them and find the key on the piano which corresponds with a particular note. Okay? Now, okay, let's start with the first stage, the cognitive stage. In this stage, you read the notes on the score in front of you, and you translate, so to speak, these notes to movements of your fingers when you actually play the notes on the piano. Step by step, looking, copying, looking, copying, looking, copying. That is the first stage. So this stage takes an enormous amount of effort. It's quite slow, you know, the performance is slow. You make a lot of errors, and you can easily, let's say, use feedback in order to improve your performance, because it's just a matter of step by step playing each and every note. You listen to yourself, you hear yourself making mistakes, you try to correct them, and you try to have to arrive at something like a sort of smooth reproduction of the notes which are in front of you. That is the cognitive stage. Conscious attention, a lot of effort, slow performance, easily modifiable. Then we arrive at the associative stage. In this stage, you start to automatize the strategy, or the playing of the notes in this case, and you start to gradually build up a sort of program which can be performed automatically. Now you can imagine that when you have this score in front of you, that there are particular parts, systems which you can easily reproduce because they are quite easy to do. So you have the easy, let's say, sequences in the score which gradually become automatized. So you just see the sequence and you play the sequence. You don't have to copy all the notes into finger movements, but you just play the whole sequence because it's so easy. Now, you gradually create these chunks in the performance, chunks of automatic performance of sub-parts, let's say, of the whole piece you have to play. So you gradually build up these chunks of automatic performance. In between, there are the difficult parts which do need your attention, which do need the copy-paste, copy-play kind of performance. But you can imagine that gradually the number and the size of the chunks of automatic performance increase until a particular moment, a very happy moment, in which you can play the complete score automatically, having a look at the notes, but just letting your fingers play the piece as they have learned to do so. I remember I once saw a masterclass of Arthur Rubinstein on television. You know, he was a very famous pianist, and he was telling his students something like, you don't have to look to your fingers, because your fingers, and your hands do the work themselves. You have to concentrate on the music, on the emotional qualities of the music, and try to put that into your playing. Now, when I was watching that particular masterclass on television, I was thinking, okay, well, I'm an amateur pianist myself, so I thought, well, it takes me a lot of time in order to arrive at that moment at which you actually are able to perform the whole piece of music automatically. But that is the end of the associative stage. Then you have an automatic, let's say, sort of program which runs smoothly, fluidly, rapidly, without much attention, because it's completely automatic what's being done. But you cannot easily change any mistakes or wrong notes which have slept into this performance. So it's very difficult to change it because it has been automatized. The third stage is the autonomous stage, which is a stage in which you start to improve your performance also under, let's say, difficult conditions. So first you play the piece at home without any audience, and then you gradually start to increase the level of difficulty of the conditions by inviting your friends, perhaps, or by even moving toward a concert hall where you perform the piece. It's becoming more and more difficult to play the piece, but you gradually you continue, practicing until you are able to perform the piece in these new under these new conditions. So that's the autonomous phase. Okay. So that is a gradual organization of procedural knowledge, starting with strategies, the step-by-step performance with conscious attention, and ending with the automatic performance without conscious attention as a skill, which is run smoothly, but which is difficult to change, as I said. Okay. Now we return to the concept of transfer. So the low road transfer, as it is called, is the transfer by practicing, as it is said here, generalization over cases. And the high road transfer is what we discussed with the concepts, in which we consciously abstract, certain characteristics and use these abstracted characteristics to identify new examples of a particular concept or theory. You could try to combine these two views on transfer as a concept as such. So we have two types of transfer: the low road transfer and the high road transfer. The low road transfer is associated with developing skills, acquisition of cognitive skills, and the high road kind of transfer, the abstract conscious approach, is associated with the the transfer of knowledge concepts being applied in new situations. Okay, so now we have discussed the unit of organizing knowledge, and we have an idea basically about the way people make use of declarative and procedural knowledge.